Next, we are going to take an experiment. Now, the title of the experiment is Coefficient of Static Friction between two surfaces in contact. Now, these are the apparatus you require. A wooden block, slotted mass, stroke hanger, a wooden plane with mounted pulley. All right? Now, the method: weigh the wooden blocks and note the mass of the hanger. I will take you to the lab now, where the children will carry out this practical. Now, the students have carried out the masses using a digital balance. All right? Now, if you can see, the mass of this is 59.0. The mass of this is 65.2. The mass of this is 66.2. And the mass of this is 48.6. The mass of this is 52.5. Now let's see. A thread is tied to the 59.0 mass and is passed through the pulley, and then there is a mass hanger on it. Now, the students will proceed to load the masses. As they load the mass on this, they will start by adding up the slot masses on the mass hanger until this particular block is about to move. Then we will note the force on the hanger and on the block. Now, the first item is to attach one end of the thread to the wooden block. We've done that. And the other end to the hanger and pass the string over the pulley. We've shown that has been done. Now, place known weights on the hanger until the block is about to move. Note the suspended weight on the hanger, FG, that is plus the mass of the hanger. We'll go on to load II. Now, the mass of the block, as we said, is 59.0. Now, the learner will proceed to load a mass of 5. Don't pull it out. So, now the block has been measured using the digital balance shown to be 59.0 grams. Now the student or the learner will proceed to load the hanger with a mass of 5 grams. You see here that the mass, the block has not moved. He will now add another 5 grams, making 30 grams. You can see here that the block has started to move. Now the mass of our block was 59 grams. Now enter it on the table, 59 grams, all right? Now if we divide 59 by 1,000 and multiply by acceleration due to gravity, which is 10, that will give me 0.59 as my normal reaction. Are we there? And there, now, the mass of the mass hanger was 20 grams, all right? When we loaded it with 10 grams, it becomes 30 grams, all right? By the time we divide 30 grams by 1,000, then multiply by 10, we'll get 0.3 Newton. Are we there? So we are going to proceed to load the block again. Mark you, the initial block was 59 grams. We are going to add another mass on top of the 59 grams and then proceed to load the hanger until the block begins to move. Then we can now enter our force of friction. Are we there? Now let us proceed to the practical. The students have measured the mass of the second block to obtain 65.2. So I placed it on top of the first block, which was 59.0. That gives me 124.2. Now, I'll enter the new mass of our block as 124.2. That is, I've added our new 65.2 plus 59.0 to obtain 124.2 gram. Now if I divide that by 1,000 to convert it to kilogram, and then multiply by 10 to make it a normal reaction, I will obtain 1.24 Newton. Now let's proceed to load the hanger. Mark you, the mass on the hanger, our initial hanger was 30. We're going to add masses on top of the hanger now to see the mass that will make it to move. Okay. Now, the learner will proceed. Mark you, on the hanger is already 30 gram. All right? He will proceed. You are drawing it. Okay. Now, the student or the learner will proceed to put in 20 gram. Now, notice that the block has not moved. Now, initially there was 30 gram on the hanger, and now he put in 20 gram. That means 50 gram has been added. He will proceed to add another mass of 5 gram. Let's see whether the block will move. Yeah, you can see that the block has moved. The learner added 25 on top of 30 gram. Are we there? Now, 25 plus 30 gives us 55 gram. Now, if I divide, that's 55 gram, divided by 1,000, converts it to kilogram, right? And multiply it by 10, I will obtain 0.55 Newton. We will proceed to load the block with another mass, and then also proceed to load the hanger until the block moves. The learners have taken the mass of this and have shown it to be 66.2. Now if I add, mark you, if we total these two masses, we obtain 124.2. Now if we add 66.2, that will give us 190.4. I will proceed now to enter 190.4 as the mass, total mass of the block now. All right? Now, if I divide this by 1,000, I convert it to kilogram. All right? Multiply it by 10, it gives me a force of 1.90. Now, mark you, the total mass of the block now is 190.4.